Welcome to Module 4, in which we're going to discuss probability. Probability is always an unusual topic in this class because we're going along, we're studying this nice continuous process of statistics and then probability. And so I want to try to explain what the use of probability theory in statistics is and how we're going to use it. And I'm going to start off with a semi-rhetorical question, which is, why do we use statistics? And you might say, Matt, remember you told us in the very beginning of this course why we use statistics. Statistics is a process for making decisions using data. And you're right. But one of the things we've learned is that there are issues with this process. So in the last module, we saw that people can use statistics to misrepresent data and mislead others. So that's one problem with statistics. Now, hopefully by the end of this course, you'll be an intelligent enough and a savvy enough consumer of statistics that you'll be able to troubleshoot and kind of figure out when these sorts of things are occurring. But there are other issues with statistics too. So, for example, when we talked about the George Floyd case and the discussions, there's kind of a question as to whether or not we can even use statistics to answer this particular problem. And it's very interesting. You know, I hear thousands of statistics and I don't really pay attention to many of them. But there's one statistics that always blows my mind. I'll tell you what it is. In the last 5 years, we've produced and recorded more unique information than in the entire remainder of the history of mankind. So if you put together all the unique information that we've generated and recorded in the last 5 years, it's more than since the dawn of civilization up to 2015. That's an amazing fact. And I'll tell you why it's even more amazing, because you would think with all that information, with all that data, it would be easier for people to come to a consensus and a mutual agreement. And yet, what do we see? We see the opposite. So in the case of an issue like George Floyd, what happens? Well, one side uses some of the data and claims that that supports the position that yes, there are police that, are involved in brutality, but they're isolated incidents and there's no evidence of systemic racism. Okay? But then you have another side that says the complete opposite. Sometimes using the same data set, believe it or not. And they claim, yes, absolutely, there is clear evidence that there is systemic racism, institutionalized racism. Who is right? Nobody knows. And so you got to begin to appreciate, when you did that discussion, how difficult a problem this was, how multifaceted it was, how many variables it depended upon, and how your answer could depend upon which variables you choose to analyze. So this is another issue with statistics. Now, there's a third problem with statistics, and that is it makes mistakes. And so you might ask the question, well, why are we using statistics? Is there perhaps some other alternative method that we could use besides statistics to make decisions from data? And the answer is yes, there are other methods. But what I'm going to try to convince you of, or the statement I'm going to make here, is that statistics is still the best method. And I'm going to explain why and how probability comes into this. I want to do so by way of a hypothetical situation. So right now, all the major aerospace and avionics leaders are beginning to create production lines to fabricate their own portions of planes and whatnot. And let's suppose you get a job after graduation at one of these big companies, maybe Rockwell Collins, okay? And you're designing some sort of panel And of course, you need to get components, you need to buy components. And right now, everyone is, of course, watching their budget, right? And your boss is telling you, hey, you can't spend over X amount. So you're looking around and you find this vendor that offers the parts you need for really reasonable price, lower than any of the competitors. But you also know that this vendor has a reputation for sometimes delivering less than high quality parts. So you don't want to be manufacturing planes that fall apart. Now, usually when a situation like this is transpiring, there's a contract between the vendor and the buyer. And sure enough, you look at your contract and it says that if more than 7% of the components you're going to purchase from the vendor are defective, you get to return the whole lot. And in fact, they have to pay you an inconvenience fee for wasting your time and delaying your production line. Okay. So here's a decision we want to make using data. Tomorrow, should you reject the lot that's coming into your line? Now, I'm going to introduce two methods we could use to make this decision using data. The first, of course, is statistics, but the other is astrology. And you might say, oh, come on, astrology, really? Well, I'm going to make the argument that astrology, on the surface, uses the same process as statistics. Each of them collect data, they summarize the data, and they make a decision based on that summary. So in the case of, say, a fortune teller, what would they do? Well, they would, read the palm of your hand, get your birth date, a bunch of other information. A statistician, of course, would also collect data. He'd wait till the shipment came in. He'd take a small sample and test each component in that sample to see if they were defective. Each would then go ahead and summarize their results. So the astrologer would consult various books and whatnot and do astrological calculations and find out which house was in which moon and which sun and all this sort of stuff, right? And the statistician would employ the exploratory data analysis that we talked about previously. He would go ahead, he would visually summarize the data by making plots, and then numerically summarize the data by computing the relevant statistics. And then each of them would render a decision. The astrologer would either tell you yes or no as far as accepting the lot, and the statistician would do the same. They use the same process, and neither one of them is foolproof. So how do we know that statistics is really that much better than astrology? Okay, so first of all, we know that we make mistakes using statistics. And I always kind of chuckle when I hear somebody say that it's been statistically proven, because you can't prove anything in statistics using data. We saw in the 2016 elections, we had a lot of really good people, perform many studies, and they were all spectacularly wrong. It happens. But there is a difference between the type of errors that happen in statistics and the type of errors that happen in astrology. And here's the difference. Even though when you use a particular statistical method, you may be wrong on any particular, study you do, nevertheless, we can assign a measure of reliability to the statistical methods we use. In other words, I can't tell you on any one single experiment if it's going to work or not, but I can tell you the percentage of times the method will work. Measure of reliability. No astrologer can do that. No astrologer can say, I'm going to be right 95% of the time, and then we can verify that. So to give you a little bit of an example of what I mean, right now, every single poll, right, every single day is talking about the elections. And so you may hear something in the news that what percentage of people are going to support Biden in a particular state, and maybe they say it's 46% plus or minus 2%. It's called the margin of error. In other words, we think the true percentage is within 2% of 46%. In other words, it's between 44 to 48%. Now, what they don't tell you in the news is that that is a 95% confidence interval. And what that means, that 95%, what that means is that's how reliable the method is. It means that 95% of the time when they compute these confidence intervals, they're right. The population percentage really lies in that interval. So how do we do that? Well, this is where probability theory comes in. Notice that when I said earlier, kind of my definition of statistics, I left out a really important word that I initially had in there. Statistics is a rational process or science. Rational means that there is a rational basis for what we're doing. In other words, there is a reason underlying what we're doing that we know for a fact is correct. In statistics, that rational basis, the reason why we know statistics is correct, is probability theory. Because probability theory is not statistics, it's a branch of mathematics. And so this is the foundation, the reason why statistics works. It's due to probability. And we know that it's correct because it's mathematics, and in mathematics we can prove things, so we know for a fact that they are true. Now later on in the class we're going to talk about a lot of applications of how we use probability theory. And we're going to talk about how we use it in inference, how we use it in prediction, how we use it in estimation, and so on. But the key thing to understand is that the foundation of statistics is probability theory. And actually later on, we're going to learn a theorem from mathematics called the central limit theorem. And it is the heart of all statistics. It's not too much of an exaggeration to say that it literally sits at the center of all statistics. Without that, we can't do any really meaningful statistics. So we're going to keep coming back to probability theory. And in this module, we're going to learn the basics. We're going to get our feet wet. We're going to learn about some basic concepts and how we do some computations with probabilities. And as we go on in the subsequent modules, we're going to keep coming back to probability and seeing how we use it to answer our statistical question. So stay tuned.